Zooming here, but what's been so great about this platform that Jan is in Chatham, I'm in Sarnia, Heather's up in Thunder Bay, and Rod, you are in,
I'm in Kamoka,
in
and
Kamoka, yeah.
I'm going to let you know I hit the record button so that we can capture this little sort of welcome screen. And it's about 3:44. So if you want to start in about 30 seconds, I think we should be good to go.
Absolutely. So we changed our start slide because this seemed to be a little bit more environmentally relevant. So are we going to do our second slide, Jana, do you think?
Why not?
Okay. So that's Heather. We'll have to click us on to the next page. We'll ask you to get your annotate buttons together, or tool, I guess it is. And so we know we have 18 people dialed in today for our Zoom session, but we are wondering how big the actual viewing group is. So for example, using our 5 frames, I'm going to be showing that I'm here by myself today. Make my little mark. So if you could annotate your size of your viewing group. I'm going to tidy that up.
So that's me. I also am alone. So I put in 1 right beside Pam's. For those of you who are not sure how to do that, that's up at the top, right, Pam?
Yes, yep.
Under view options.
Mm-hmm. And if you're on an iPad, it's actually at the bottom, I think.
Okay.
Nice. It seems like people are figuring out the annotation tool. That's good.
I like it.
So just to confirm, we are talking addition and subtraction today, and Heather's going to be leading the conversation with us today. And we're advancing along the continuum a little bit. So we're kind of starting those strategies where students have to start working with the numbers, and maybe starting to see some different thinking and efficient thinking going on. So it'll be interesting to see what connections you make with your students today.
And just while people are finishing that up there, Pam, I just wanted to make a point worth mentioning that Heather shared last week, and she talked about the value of this work is using the continuum to help the teachers to know what to do next with their students. And so, we want to thank Heather for all the time that she's invested with us and guiding us through this learning all month long.
Yeah. Yeah, we were chatting a bit today too about like those teacher actions that we do, like things like number talks. So within your number talk, the action you take, but somebody's like, well, what push do I have? What strategy do I want to take forward in my number talk? Or if I'm working with the students and we're consolidating, what do I want to have students to remember at the end? Yeah, this is a great one to do. And I know today Heather's going to be sharing with us something like, how do you know for sure that's the next step to take? So what are the skills students have to have before you take that next step? So that's good. So we'll pass it on to Heather. We'll get started in our addition and subtraction group today. And we welcome her expertise. As I said, she's with us remotely from Thunder Bay, and we're going to talk about addition and subtraction today. So Heather, are you ready to take charge? She seems to be clicking through all the slides right now.
Yes, I was just trying to catch up to you because we kind of sat on that other slide for a bit.
Yeah.
And you just, you kind of warmed us up and got us ready to go. So welcome everyone. You guys are troopers, those of you who made it. And if you are catching us on the replay, then thank you for joining us on the back end as well. We really appreciate everyone who attends either live or takes the time to watch the recorded session. Yeah, exactly. So thank you very much for that. I guess I forgot to turn my video on. I love that picture of me. I'll put that back up later.
Yeah.
That's the one that you wanted? That's the pic?
Yeah.
We all have those favorite archive photos. I look good that day. Yes.
Yeah, I'm not changing that one ever.
Yeah.
Okay. But here we go. We are going to talk a little bit about addition and subtraction. So just trying to put our head space back into what we did before. There was a slide that I clicked through about, that developmental idea that mathematics understanding is a developmental trajectory, this continuum. So students, there's more to it, of course, than just like moving to the next strategy. The student actually has to have some developmental shifts in order to be ready for the next strategy. And certainly today we are going to dig into that, because we're moving from the counting strategies that we looked at last time into the working with the numbers. I'm going to get to that in a minute.
Yeah.
I wanted to put this slide up because I wanted to remind us what question we were talking about. So the question that we looked at last time we were talking about addition and subtraction was this one. Let's pretend that you have 6 fish crackers and I give you 8 more. Do you know how many fish crackers you would have altogether? So that's the question that we were looking at, and we're going to continue our discussion today with this question kind of in the back of our minds, or maybe the front. We'll see. Yeah. We'll see where it ends up. All right, so our continuum that we're looking at is pictured here, and I've put a red line in right here to show kind of where we got to. We looked at counting 3 times last time. We looked at counting on and the 2 different ways, whether they're using a direct model on this side or whether they're counting on and tracking on this side. And we also looked at counting on from a larger number. And those are the 3 main places, the main strategies that students are going to use when they're adding a problem like the one that we're looking at here with the 6 fish crackers and you get 8 more. And basically, I put this line in to really show this shift from the counting phases, these are both counting phases, and then into the working with the numbers, which is where we're headed to for today.
And
you made a point, Heather. Oh, sorry,
go ahead,
Pam.
Jana. You go ahead, Jana.
You made a point last week, and I wanted to make a note of that as well. You had said to me, and it really stuck with me, that what do students need to be able to do, to know, and to understand differently in order to access more sophisticated strategies? And you were talking about them being developmentally ready in order to be successful with these strategies. And I think that really points to what you just said to us.
Mm-hmm. Yeah, it's certainly, I'm trying to go backwards now. We'll see if the slide deck lets me. There we go. Mm-hmm. With teachers will tell us all the time that, for example, they're working with a student who's counting 3 times, and they've been trying to teach them counting on. They've been trying to teach them counting on, and they just cannot get it. It doesn't matter how many times they tell them that they don't have to count the first set again, that the child counts the first set, and that's because that child does need to count the first set, because their understanding of cardinality is not quite where it needs to be yet for them to not have to count the first set. And so, teachers already know this, and so I find that when we start looking at the continuum, what the kids have been doing or are not able to do all along makes sense to teachers, because they've tried to teach the strategies and the kids can't do it. Mm-hmm. And that's because that we need to actually do something else. We need to support some kind of mathematical learning a little differently than and then they'll be able to get in on it. It's almost like a light bulb in a way that goes off for some kids. I just wanted to talk. Sorry, and Pam, you wanted to say something? I was going to
say that line there, like when we move from counting to adding on, the working with the numbers, like that line it's almost like a fence you have to get over, or there's something there that's just blocking that, and you're like, come on over with me. but I know you have an analogy too.
Yeah, well, and it's also sometimes I think about it as like more like a chasm, and we have to sort of build bridges over top of it
There you go.
to help them to get over those phase lines. Those phase lines are actually quite significant. They look like little tiny lines, and that's why I made this one a little bit bigger, so that we really appreciated how big that transition is for kids. So yeah, so this analogy that I often talk about is this cornfield analogy. So let's pretend that Pam, you live on the other side of this cornfield from me, and I walk up to this cornfield. Of course, it's so tall, I can't actually see your house. So how do I know how to get over to your house? Well, I'm just gonna start walking through the field. Hopefully the farmer's okay with that. And I'm just going to kind of break trail through this field. And that's kind of what our students are doing when they are when they're solving problems. They don't actually necessarily know exactly how to solve a problem when they're doing it for the first time, and they're just trying to figure things out based on what they already know. And then eventually they'll get, if they, hopefully eventually they get to the correct solution, and hopefully eventually I get to your house. But the path that I cut might not be the most direct path. It might be, a little bit this way, and then, oh, I should have actually gone the other way, and then a little bit that way, and oh, I should have gone this way. So, it might not be the most efficient path, let's call it that. But the more I do it, the easier it is. So tomorrow when I come to the cornfield, am I more likely to take a different route that I haven't actually stepped on yet? Or am I more likely to go back to this one that I've now started to make it a little bit easier to get through? And most people can appreciate that I'm actually probably most likely to come to this path and do this one again instead of cutting a new spot, a new trail. And cutting those new trails is like working with the number strategy for the very first time, or some other, it could be even counting on. If we're counting 3 times, then counting on might be sort of a new spot to try out. And so our students, just like us, we are more likely to re-step the same places that we've already gone than we are to try something completely new. And what sometimes happens, especially with counting on when it comes to adding, is that we just keep going back and keep going back and keep going back until we actually create like this massive, really quote unquote comfortable trail to walk on, even though it may not be terribly sophisticated. It certainly is going to get me to your house. And one of my colleagues here in Thunder Bay, she talks about the fact that the kids get out like a sidewalk paver and like make this like really, really inviting, because they just practice that strategy so many times that they can like strap those rollerblades on and like really go fast. And actually this is where efficiency becomes a bit of a problem, because it actually is quite efficient once they get this fast at it. You can imagine if this trail was paved and they had rollerblades on, they're going pretty quickly. And as a matter of fact, if I wanted to go back to the, if I was thinking about stepping into a completely different spot through this cornfield to get to your house, Pam, in a different way, it would actually take me a lot longer, and it would be a lot harder than it would be to go on this path. So I think that, you really, we want our students to get confident and comfortable enough with the strategy, but not so comfortable that they're getting out the sidewalk paver, unless it's already a really sophisticated strategy. And sophistication and efficiency aren't exactly the same, so we want it to be a bit more sophisticated. So that's where our working with the number strategies come in.
Well, just listening to you too, the word that kept popping in my mind was trust too. Like, I can trust counting 3 times. So now you want me to do something different. So again, that I'm fast, I'm accurate. So why would I want to trust leaving to try a new strategy too? So knowing your learner, that's interesting too. Like, because I know some of our teachers have said, like, kids are going, oh yeah, count on from the larger number. I'm good. I'll stay here forever. And like, they'll even say, yeah, I'm good.
Yeah, it takes a lot to transition over this line. And so what can we do to help kids make the first few steps over this line? Because this can be a bit of a barrier, like you said, like a bit of a fence. And so what are some of the things that we can do to help our learners just make that first transition into working with the numbers? So here's just a few things that they can do. So what we really want to do is help deepen their understanding of that part-whole relationship that we see on this slide before. You can see this red line. I brought it all the way down because it touches in on this part-whole relationship, because in order to access this next layer of strategies here, we have to have a deeper understanding of this part-whole relationship. And so that's really what we're going to be working on. So what are some of the things that they need to have in order to access some more part-whole relationship? Well, they need to have some facts under their belt. So 1 more than, 2 more than, and their small doubles. So 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5. They need to have those ones under their belts as a fact. And so with 1 more than and 2 more than, those are facts that they learn through counting on. So that we're right in the right territory. We also can carefully select numbers and problems to strengthen their understanding of the part-whole relationship. So the problem that we just posed was you have 6 goldfish and I want to give you 8 more. How many would you have altogether? Which is a pretty complex problem with pretty big numbers. But if I was working with a student who I was just trying to get them in on working with the numbers, I might ask them something like, if you have 3 goldfish and I give you some more, and now you have 6, how many goldfish did I give you? And so that structure of problem helps them to do something a little bit different than counting, because they actually don't know how many I gave them. And I'm picking the numbers very specifically, this small double, so that they can get in on the idea that maybe they could solve this one without counting, because they know something about 3 plus something gives me 6. And we also want to use maybe some quick images to support the connection between the doubles and the near double. So if I was using a 10 frame, perhaps I would show a quick image like this one. So a couple of 10 frames can sometimes be helpful here. So I'm just gonna carry this over. There. So I might just do a quick image where I show that quickly and then say, what did you see? How did you see it? And hopefully they'll talk about the fact that they saw that 3 plus 3, that's the double, and then the 1 more, so 7.
You talked about they have to know those small doubles.
Yeah.
But is that also part of the part whole? Like, so they've got one part, they've got another part that's missing, and then to find the whole?
Yeah, okay, for sure that helps deepen their part whole, how they can use that part whole relationship. They've already kind of got it started there with knowing those small doubles, but using it in a slightly different way helps to strengthen that part whole relationship, that part whole understanding. And then here's a game at the bottom. I love this game. This is doubles plus 1 bingo. And so all you need for that one is like a blank bingo card, and you can get the kids to fill it in, and they just roll a 6-sided die, and then they have to cover the double of the number that they roll, or sorry, the double plus 1 of the number that they roll. So that's pretty easy game. Oops, to construct. Wrong. I meant to click, not slide. Okay. So I wanted to take a little bit of a look at what we can expect some of the strategies to look like once we do get into our shift here into working with the numbers. And one of the first ones that we're going to see for sure is using near doubles. Now, using near doubles, you can see, is located right above using a known fact on the continuum. And that's because using near doubles is actually just a specific case of using a known fact. So sometimes people will ask me, like, what's the difference between using a known fact and using near doubles? And in reality, there really isn't much of a difference. It's just that the doubles does happen first, and so we kind of highlight it differently to give teachers something to kind of work with. It helps them to know what numbers they might use, like what I showed you with the 2, the 3s, and then the 4 extra one. It helps teachers, I think, to know that these doubles will be the first ones to come out. But it really is just a specific type of using a known fact. I have a video here to show of a young girl, my daughter Kale, using a near double to add 6 plus 8. Oh. Let me try something here. I assume you guys didn't hear that, Pam?
You are correct, right, Jana? You didn't hear it either?
Yeah. No, we did not.
No.
Okay.
She has important things to say. We need to make sure she has the voice.
We tested this out last night, and yep. It was working fine. So I don't know why it's not working now.
Is your volume up? I assume it is.
There we go.
Oh, there we go.
What if you had 6 gummy bears?
Okay, sorry everyone. Small technical glitch.
Okay, can I ask you a math question?
Yeah.
What if you had 6 gummy bears and I gave you 8 more? How many gummy bears would you have altogether?
6. Add on 8, so that would be like 6 plus 6 plus 2 more would be 14.
And how did you know it was 14?
Because of 6 plus 6.
And what's 6
plus 12.
I see. And then what? Once you had 6 plus 6.
And then I added 2 more. And that got me to 14.
All right. So we see there Kale solving that 6 plus 6. And we hear her talking about the 12. So it's really common when students are using a near double on this question for them to think about 6 plus 6 equals 12 and use that as a starting point for calculation. And I just wanted to, I'm just going to slide over to the document camera for a second because I want to talk about 2 things as we're looking at the strategies. And one of them is, like, if I was sitting at the carpet working with students, including Kale, and Kale says this solution, what would I do to help other students get in on it? So, and what would I do to help Kale and other students who do understand the strategy already? So there's basically 2 different things that I'm going to do other than question her like I did in the video to get her to actually share her thinking a little bit more explicitly. But I'm going to make use of some modeling and scribing to help. And I know that one of the things that you can read a lot about online right now is the idea that math is very visual. And, you know, it's not just visual for visual learners. All students benefit from a little bit more visual use of visuals in mathematics. We don't want them to just count, but the visual does help them. So if if Kale was sitting at the carpet with me and we had all just looked at, 6 plus 8, and she gave her strategy, and I was thinking that there were some students in my room who are still counting on, and it might benefit them to see what she's talking about. So what I might do is pull out my 10 frame and then question Kale a little bit more, just like you saw in the video. So how did you start? Where did you begin? And she would articulate again, just like she does in the video, that she started from 6 plus 6 equals 12. And then when I asked her what she did then, she would say she added 2 more. And I would probably put those 2 more in there like that and say, and I would ask her how she knew that that would be 6 plus 8. Because I think that's one of the questions that's maybe missing from that interview is like, how does that 2 more relate to the 8 that we were thinking about? And I would probably, for the students in my classroom, put those 2 in like that so that they could see the 6 and they could see the 8, but they could also really see those 2 6s that Kale's making use of to work her 12.
Yes, and I agree there with Sally in the chat there. She said, what can we do to help other students get in on this strategy? And that's a real nice way to show the rest of the class what Kale was thinking.
And then, of course, there are also the fact that Kale might need at some point to be able to write down her thinking like a mathematician. So I might talk to Kale, and if a lot of my class is already using a double, maybe I would do it this way. And depending on her age, I put this as came automatically as an equal sign over here because that's typically what I do, but this does kind of depend on her age. So I'll show you another method for grade 1s after, but grade 2 and up, I would probably do it like this. So for Kale and for other students who already know this strategy and they don't need the help of the 10 frame, what they might benefit from is seeing how mathematicians would write that thinking. So we have 6 plus 6, and that she knew that in sorry, I did this one wrong. 6 plus 6 equals 12. That's how she started. But she actually knew that she wanted 6 plus 8. So she has to link this idea to 6 plus 8. And she knows that she had to add 2. She has to add 2 there. So she knows that she actually has to add 2 to get to the 14. So she's playing over equivalence here. She's got some algebraic reasoning going on that if she adds 2 here, then she has to add 2 there. And so that's why with the 10 frame, we started with it being the 6 and 6, and then we put the 2 on to make it the 8, because she's working off from another known fact.
Mm-hmm. And just, it's interesting, like, because we are going to have those learners in the class that will need that visual representation again, and from the flash activities they're doing, that's a nice connect. But then there's going to be other kids that are ready for this. So it's nice. Yeah. Thank you for showing 2 options of that, because I think as a junior teacher, I often have kids that are stuck with that drawing the picture piece, and maybe it's because they don't know how to document. I haven't modeled for them how to document what their thinking was numerically.
Yeah, it's important for them to know how a mathematician would write their thinking with number symbols. Once they are, if they already have, if the thinking is hers, like for Kale, she would understand this. Other kids might not be ready for that yet because they're still just trying to get in on the strategy from the very beginning. All right, I actually have another video of Kale solving the same problem, but in a slightly different way, because I asked her if she could think about it in another way.
What's another way that you could solve 6 plus 8, Kale?
It's where you have the 6 and then you have the 8. You take 1 off the 8 and you put it onto the 6, and there you have 7 plus 7, and then it equals 14.
And how did you know that you could take 1 away from the 8 and give it to the 6?
Because it's like taking one thing from from one number and then putting it onto another number.
We were talking about gummy bears there. Does that help you? How did you know that you could take one of the gummy bears and give it to the other one?
Because this question is...
I'm just going to pause it there because I'm trying to get her to articulate her thinking. And so sometimes it helps them to go back to the context of the problem so that they can really dig into that context and help them out. And if she had been in a classroom with other kids trying to understand what she's doing, because it's fairly complex mathematics, then it might have helped them to rethink about the context, but it doesn't actually pay off here, but it is a teacher move that I often will use. Trying to get it to play again. It's giving me a hard time. There we go.
It's just sometimes how take off one number and then put it onto another number, or just do it where two of one of those numbers equals this thing, add on the number and that. So
could you show me with the cubes how you know that if you had that you could do that?
So here we have 8.
And what else do you need?
And here we have 6. So if we just take one off of the 8, you can put it onto the 6. And then there you have 7. And it's like sharing.
All right, so there she is. She's talking about, and I would do something very similar with if she was in the classroom. Can she actually use a manipulative to help show what's going on there with the math? And of course, she's able to there, and it's always nice if the kids can do it on their own, and other kids can ask them. They become the expert at that strategy. In some classrooms, they might call that Kale's strategy whenever anybody uses it for the whole year. And so that's another way that they can sometimes use the doubles. If the numbers are 2 away, like 6 plus 8, one way that they'll use near doubles is this idea of compensation. And so I like what she did there with the cubes, but if I felt like I wanted to use a visual with the 10 frame, I might set it up like this. So notice I've got them in 2 different colors this time, because I think that that's helpful, because I'm going to take this one over here and put it over here, so that hopefully the students can see that it was originally with the 8, but I moved it over here to make that 7 plus 7 that she's using, because that's a double she knows.
And going back to what you were saying, bringing the context into the problem there with the gummy bears at the end, I thought it was really important that she said it's like sharing.
Yeah, sharing
right?
those
and
gummies.
So it was like, that's right. So
yeah, it's interesting that she said that. I mean, they will bring, of course, what they understand about the real world to the mathematics. So it's helpful if we know the kinds of experiences that mean something to them. If I was trying to help Kale be able to write mathematically her thinking, this is how I would do it. So she knows that inside the 8, she's got a 1 and a 7. And she's just she wants to put that 1 with the 6 so that she can use a double that she knows, which is the 7 plus 7. So that's the 14. And so that's how I would write it for someone Kale's age, she was about grade 2 at that point. And for grade 1s, we would sometimes write it like this, where you would decompose the 8, and then you can put that 6 and the 1 together to make the 7. and then bring the other 7 and then add them to make the 14. So this is a strategy that sometimes we've found that grade 1 teachers are finding is a little easier for their students than all of this writing.
Now, but talking about jumping that fence, they're going to need to be able to know what's inside of 8 even before they are able to start adding that 6 and the 8, right? Knowing that inside of 8 is 1 and 7, right?
Yeah, for sure. Part of getting over that fence or breaking new territory through that cornfield, however you want to think about it, knowing flexibly how to decompose numbers is something that they're going to need. And we're going to talk about that as we look at the next couple of strategies. So the next one that comes to mind on the continuum is using the 5 or the 10 anchor. And I don't think we're going to spend very long here. You guys were saying this isn't one that you see a lot in classrooms, but I think as teachers spend more time working on how numbers are connected to 5, it is one that we will see more and more often. I don't have a video of it, although my eldest did use this strategy a fair bit when she was younger. I just didn't, take the video that I probably shoulda, coulda, woulda. Hindsight. She's 13 now, so she doesn't use this one very much anymore. But I'm just gonna talk it through with 6 plus 8. What students will talk about is finding the 5s. Students who use this strategy know how to break apart numbers to find 5 plus something. So they know that the 6 is 5 and a 1, and they know that the 8 is a 5 and a 3. And they also know that 5 plus 5 is 10. And when they know all of those pieces, then they often will use the 5 anchor. And so then they will add the extra bits. So they will know that inside the 6 is a 5 and a 1, and they'll know that inside the 8 is a 5 and a 3. And they'll talk about putting those 2 5s together to make 10, and then working with the extra bits. So 1 and the 3 is 4, so 14. And they really, I guess how you can tell that they're doing this one is with 6 plus 8, it's fairly easy to see it because they break up both numbers to find those 2 5s that they're going to put together. And they tend to be, students who use this, I think, tend to be a little, they can get a little stuck in always looking for the 5s. So, and they get stuck there. It's like that cornfield thing. They start to pave this path. Finding the 5s is easy, and as long as they know the extra bits, they can put those together. They just need to develop a little bit more flexibility in terms of other ways to break up numbers other than just finding the 5s and the extra bits. And so they're just still working on those decompositions other than to the 5 anchor. Sorry, go ahead.
I was just thinking about how valuable it is for the manipulative. Like when the student did the linking cubes, and then she was able to see that they were doubled. But then when you model it using the 10 frame, you're able to see a different view of it. So just like that flexibility starts to come in. And then this flexibility with using color in the 5 and 10 frame too. So how that really helps students see where the thinking's coming from.
Yeah, I hope so. I think there's ways, there's not the only way to do it, how I've shown it. There's other ways that still allow you to see all the thinking, but that way that I showed you is one way. I just wanted to show you for a student using the 5 anchor, if you were going to use scribing for that student so that they would know how to write their thinking mathematically. So they are breaking up both numbers and finding those 5s. It gets a bit messy with the scribing, unfortunately. There's sort of no getting around it. And so some people make it a little less messy by putting in kind of an extra step. Depends on what the kids say, but basically they are decomposing both numbers and really looking for those 5s. I have seen some teachers do some really beautiful things with color to help out here too. my intermediate teaching roots are coming through here, though, and some primary teachers I've worked with have done some really lovely things in here with color to help their students out. Okay, I just want to, we're almost done. We've got just a few minutes left, and so we are moving into the territory of up over 10. And to me, this is one of the most important strategies in this early green area, because this is our like powerhouse strategy. Alex Lawson talks about them as BMW strategies, as in the car, as in it has a lot of power, mathematically speaking. I've never driven a BMW, but I hear they're nice. That they have a lot of power under the engine, and so does up over 10. You'll see this strategy is this up/down over 10. So students can use this in subtraction when they're going backwards as well, hence the down over 10 part. So, but we're going to talk about it with addition with up over 10. And so, again, I don't have a video of a student doing this, but if they were using up over 10, they would say, they would keep one of the numbers whole and work with breaking up just the other number. So with up over 10, there's usually two ways to do it, because they can keep either one of the numbers whole. So which one should I do? Should I keep the 6 or keep the 8?
I think I would keep the 8 whole, because I want to go back to my, I know work with the big number is always beneficial.
Yeah, so some kids will keep the 8 whole, some kids will keep the 6. It doesn't really matter.
Okay.
So, you know, eventually we want them to be able to do either one,
Right.
you know, and understand that they're both, they're both equally, you know, correct, I suppose. So let's take a look. So let's pretend that I keep the 8 whole, and the student might say, well, I know that I need 2 more to make 10, and that leaves me 4 left, so 14. They might say something like that. So let's take a look at it with the 10 frame. So the student's thinking about the 6 and the 8, and they know that they need 2 more to make 10. But they have to remember they've taken these 2, so that how many do they have left? They've got 4 more. And they have to know that 10 plus 4 is 14.
That visual is fantastic, though, where you've decomposed that number, but it's still the 2 colored counters. I never thought of it that way. So thank you for that, because that visual alone is so nice in the way the one number, you've kept that one intact and you've decomposed the other one, but you've kept it as that different color. So you see where that number is coming from.
Yeah, I like doing that with the 2 colors as well. So I'm just going to try to write the scribing. So for the student who did this strategy, they don't need the 10 frame. You know, they already did it mentally. But what they might need is how to write that. So I would check back with the student and say, so what did you do first? And they'll be thinking about the 2 that they took to make the 8. So where did that 2 come from? Well, it's inside the 6 if they ask me. So I'll question them until I can say I can write what I need to be able to write. And so mathematicians would write that like that. They would decompose that 6, and they would write the 2 and the 4 that's left over there, and then they would keep the 8. And then they would try to keep the drawing and the pen frame, but it's not working for me, so I'm going to move it off to the side. And they would make the 10, and then they would come back and add the 4 and the 10 to make the 14. So this kind of scribing can be helpful for the students who are already understanding the strategy, and the 10 frame can be helpful for students who are just ready to kind of get in on it. Now, speaking of getting in on up over 10, I wanted to talk
because it's a good
about,
place to be. If it's going to be a powerhouse strategy, we want to get kids there.
Yeah.
And I think this is something that a lot of teachers have reflected with us, is saying that, okay, I know they can do this, and I know I want to go there, but how do I really know I'm making the right decision for that kid?
Exactly.
Yeah.
And also, how do we help them be ready? So back to my cornfield analogy, right? How do we help them to be able to tap into the up over 10? So there are three key things that they need to know, do, or understand, like Jana was saying, in order to use up over 10. So the first one is, and I shouldn't say that they're in this particular order. This is just, they need these three things. It doesn't have to be this order, but they really have to be able to flexibly decompose any number. When we were looking at this problem here, they had to be able to, if they needed a 2, they had to be able to break up this number in whatever way they needed to get themselves a 2. If this had been a 7 and they needed a 3, they would need to break this number up in whatever way they needed to be able to get a 3. So,
and any number or any number up to 10?
Oh, for up over 10, it's 10? Just up to 9. Yeah.
Okay.
Yeah. And then they also need to know their pairs that make 10. Again, with our example, they need to have automatically, when they see the 8, they have to know that needs a 2. I need a 2 to make a 10, so that they know how to break up the other number. So they have to know those pairs that make 10, and they have to know them really fluently. And then the last piece that they need to know fluently in order to use up over 10 is this sort of place value pattern of 10 plus anything gives you the teen, so that they don't really have to, you wouldn't want them counting the 10 plus 4 at the end, right?
Like 10, 11, 12, 13, 14.
Yeah, which they do in the beginning before they learn that pattern, but it's, it's pretty onerous when they're counting that out. So certainly knowing that place value pattern is something that they need. So how do we help them with that? Well, we've got some games, of course, in what to look for. This series is about decomposing the numbers. So these are games that support students to decompose numbers. And you can find them on page 168 in what to look for. And Handful of Dice is like one of my favorites right now. And it's a really, really easy one. So all you have to do to play Handful of Dice is you have to have a handful of dice, so 10-ish. And I have 10-sided dice here, but you can play it with 6-sided. And basically, you just pick a number that you can make using 2 of the dice that you have. So if you have 6-sided dice, 12 is your top number. And if you have 10-sided dice, then 20 can be your top number. And so what you would do is, let's say you pick the number 7, and then the student rolls the dice, and they try to find numbers that would make 7. So here I have a 6 and a 1. And I could put those together to make a 7. And then I would look for other combinations that would make.
Now, Heather, is it okay for them to use 3 dice to make the number 7, or should they stick with 2 dice?
That's a good question. For some games, you want it to just be 2 dice. And I think for this one, sticking to 2 dice is an important part of the game, because if we go back to up over 10, then what we needed them to be able to do was to decompose numbers flexibly into 2 pieces. And so we need them to have that first. If the student already knows all the decompositions by heart, and we're just playing this game for fun, they're choosing it as a fun game as opposed to a learning game, then maybe I would let them play around with some other options. But for now, I want to make sure that they get the learning from the game that I need them to have, which is actually decomposing to two numbers. Okay, last one. I know we're over time, but is what to look for on page 171, which is these are games that support learning the pairs that make 10. There's lots of other ones available, but this is a Go Fish 10. And basically, if you've ever played Go Fish, you know how this game works, except that instead of looking for a pair, you're looking for the pair that makes 10. So for example, if this was my hand, instead of finding a pair that goes together, then it's the pair that makes 10 that goes together to make us a set.
Yeah, many a competitive day in classrooms playing this game.
Yeah, this one's a pretty popular one out there for sure. And that's all I have for the strategies on the continuum that we did today were using a near double, which is a form of using a known fact, and then we did the 5 anchor, and we did up over 10.
Oh, well, thank you so much again, Heather, for lightening us with some ideas. I was just thinking about how important it is to leverage what kids know. And then then the teacher actions I make, like, choosing what numbers do they actually know the part, like, do they know that 8 + 2 = 10? Like, that's a teacher action that I can make. And Jana, I know you and I talk about manipulatives a lot. I saw your eyes get all sparkly with the manipulative conversation today.
That's right. I think it's so important to have that concrete representation first, right? It really solidifies for those kids to show what they're thinking. So.
Yeah, and I love that how, like, if some kid is moving, like showing you that, talking to you about that, and then bringing the manipulative in so another kid can get in on that strategy. Again, that's another great teacher action. Again, so thank you, Heather, for joining us, and thank you to all the people that love snow and stayed with us after school today to do a little bit more learning. And we do want to remind you that we have additional sessions coming up for one more about addition and one more about multiplication and division.
I see some questions in the chat about where to get 10-sided dice.
Yeah.
So some people are interested in that. I love 10-sided dice. I actually get them from a gaming shop myself, but I'm pretty sure you could find them, on Amazon.
That's what I was just thinking myself. I'm an Amazon shopper, and I'm sure that you'd be able to find them on Amazon.
Yeah.
But they also should be in buildings. I don't know. You might want to scout them out. I know a lot of the intermediate teachers, and I know the buildings that I'm in. They are in the buildings. They might just be more difficult to find. Yeah. Maybe ask your higher junior or your intermediate teachers, and they may have those in their rooms.
Yeah. And I think they have, there's been some box sets about dice around before, so they're even up to like 20-sided die too. So again, know your learner, throwing them out there, but slowly add them to the repertoire there. And we do want to remind you that, again, some video clips are on our blog, ELEM Pro, so you'll be able to go there and have some looks there at some games. So it's a nice time to revisit some of those games because we played them to learn and get kids talking and feeling comfortable exploring with math, but now to come back with that intentionality has been really great.
That's right. So we do have another session coming up. Thursday, we have multiplication and division with Heather. And then next Tuesday, we have our addition and subtraction with the next few strategies along that continuum to share. So thank you again, Heather, for all of your knowledge and sharing with us.
And there is a feedback there.
Yeah, I was just going to say that folks have been saying in the chat that there's a web-based app out there, web-based page out there called Toy Theater that might have the dice that you need without even leaving your smartboard.
Oh,
yeah. And our iPads and that sort of thing too.
Yeah, Sally's sharing that it's not an app, it's actually web-based, which is awesome. So thank you, Sally, for that.
Yeah. So again, last word to our participants, thank you so much for coming. Travel safely, take your time, and be aware. It's beautiful outside now. I can see the sun in Sarnia starting to glow, so it'll be very beautiful drive home, but be safe.
Yes, thank you for coming, investing your time with us. I hope it was worthwhile, and we'll see you again, hopefully on Thursday.
Thanks so much.